everyone. We are group 3 consisting of Ashley, Naval, Raphael, Jordan, and Jennifer. Today we're going to be discussing heterogeneous catalysts. Raphael, Naval, and I will be speaking. Jordan and Jennifer will take on homogeneous catalysts. Thank you. Let's begin.
This is the overview for heterogeneous catalysts. They are catalysts that exist in different states of matter compared to its reactants. Important notes include these. Unlike homogeneous catalysts, it is not involved in the reaction itself, but acts more like a platform for the reaction to occur. A common example is gaseous reactants reacting on the surface of a solid catalyst. It makes use of absorption, which is the bonding of molecules on the surface of the catalyst, otherwise known as adsorption.
So there are 5 steps to the mode of action in which heterogeneous catalysts work. First is diffusion, in which nitrogen and hydrogen gas, which we are using the example of Haber process iron catalyst, by the way. So nitrogen and hydrogen gas are the reactants, and the reactants diffuse towards the catalyst. This leads to our second step, the adsorption of reactants, in which obviously iron is the heterogeneous catalyst here. It will, the nitrogen and hydrogen molecules will adsorb onto the surface. So it's like stick onto there, not completely go through, and it will form bonds with the catalyst. In this process, bonds within the reactants molecules themselves weaken, and therefore there's lower activation energy, hence the role of catalyst. And this allows them to react easily and at the surface of the iron catalyst, thus the reaction is sped up. The third step is obviously the reaction itself. The weakened bonds allows it to go much more easier. The absorbed atoms react to form ammonia. And in the fourth step of desorption of products, the fourth step, the fourth step, the desorption of products happen. It's in which the products kind of like break bonds with the catalyst itself, and then it's released. And then the product molecules will then diffuse away from the catalyst, allowing for more reactant molecules to diffuse towards it for reaction.
Another example we're going to be using for heterogeneous catalysts are catalytic converters. Their primary function is to convert harmful nitrogen dioxides and carbon monoxide into harmless gases. The catalytic converter has honeycomb structures that are coated with platinum, palladium, and rhodium. And the reactions inside consist of the absorption of nitrogen oxides and carbon monoxides into the catalyst surface. And then the covalent bonds within the reactant molecules will weaken. This causes new bonds between the adjacent nitrogen molecules and carbon monoxide and oxygen atoms to form. This will form nitrogen gas and carbon dioxide. Following that is the desorption of the product molecules, and then they will diffuse away from the catalyst. This is a visualization of what occurs during the 5 steps. First is the diffusion to the surface. Following that is the absorption, and then the reaction where new bonds are formed, then desorption, and then diffusion of the gas away from the surface of the catalyst.